Your network must follow industry standards and protocols to operate at its best. A protocol is a series of steps that each part of your network must follow to communicate effectively. A standard is an industry-recognized approach that allows third parties to work with each other with little hassle, like a shared language. Now, let's look closer at the differences between these two procedures. Networking protocols. Whether you know it or not, you use protocols every day. For example, you use protocols when sending letters or gifts to other people. First, you decide who you want to send a gift to and what to send them. Next, you buy or find the gift. You wrap it up if necessary. Then, you write the return and sender address on the box you're sending so that the mail carrier can accurately deliver it. Lastly, you wait 1-2 weeks for the package to be delivered and for the other person to thank you for the fantastic gift. Networks work similarly. Like how you follow specific steps to send a package, network elements must follow steps to send and receive data from each other. Network cards must deliver information to operating systems. Operating systems must give data to application programs and so on. Another great example of a networking protocol is the Internet Protocol, IP. It defines an IP address as 4 8-bit numbers called octets. This makes it much easier for devices and interfaces to communicate with each other because they're using the same IP language. What is a network standard? Standards are a protocol established by industry organizations and vendors. They make it much easier for different manufacturers and clients to work together. If standards didn't exist, it would be very hard to use different products and equipment within your networks. The most used standards are within the Open Systems Interconnection (OSI) Reference Model. The Open Systems Interconnection (OSI) Reference Model. The OSI Reference Model is a hierarchy of standards that breaks down network parts into 7 layers. Each layer performs services for the layer above it. The first 3 layers are the lower layers. They focus on how computers send information to each other over a network. Layers 4-7 are upper layers. They focus on how application software and interfaces navigate a network. Now, let's look into each layer of the OSI model. Layer 1, the physical layer. This is the electrical and physical aspect of the network. Anything you can touch, see, and interact with other physical devices. This includes cables, switches, hubs, repeaters, network interfaces, and WAP. When there's a network problem, professionals visit this layer first. They try to determine if connections are poor, cables are unplugged, and if power plugs are secure. Layer 2, the data link layer. This layer focuses on MAC addresses and packets. The concern is whether packets are being sent to the correct port or computer within a network. It also detects and possibly corrects errors in the physical layer. The devices here are bridges and switches. Layer 3, the network layer. The focus here is transferring data or packets between 2 different networks. This layer included IP addresses and routers. Layer 4, the transport layer. The focus here is that packets have been transferred securely and without errors between 2 devices. It confirms that the packets were delivered and resending those that were damaged. This layer contains protocols like Transmission Control Protocol, TCP, the User Datagram Protocol, UDP, and Internet Protocol, IP. Layer 5, the session layer. This layer focuses on opening and closing communication or sessions between 2 devices. It also ensures that the session stays open long enough to transfer all the exchanged data, and then promptly closes the session to avoid wasting resources. Layer 6, the presentation layer. This layer prepares data to be used by the application layer. It manipulates how the information is represented. It can translate data from application format to network format or vice versa. It can also encrypt and compress the data to be delivered to Layer 5. Layer 7, the application layer. This layer is the closest layer to the end user or the person behind the device. It is responsible for the protocols and data manipulation that the software relies on to receive information from the user, then display it to them. Web browsers, Google Chrome, Firefox, Safari, etc. Telnet and FTP are examples of communications that rely on Layer 7. Protocols include HTTP as well as SMTP. Simple Mail Transfer Protocol is one of the protocols that enables email communications. Lesson summary. A protocol is a series of steps that each part of your network must follow to communicate effectively. A standard is an industry-recognized approach that allows third parties to work with each other with little hassle, like a shared language. The OSI Reference Model is a hierarchy of standards that breaks down network parts into 7 layers. Each layer performs services for the layer above it. Layer 1 Physical Layer, Layer 2 Data Link Layer, Layer 3 Network Layer, Layer 4 Transport Layer, Layer 5 Session Layer, Layer 6 Presentation Layer, Layer 7 Application Layer,